Okay, this is lesson 35, using three-part tables to graph. Students will graph using three-part tables. Okay, so I want to talk to you about a concept. I've talked about it before, okay? But I want to talk to you about this concept again today. So the concept is functions, okay? Remember, like, I talked about math machines a couple of months ago or about a month ago. Or let's say I had a machine here and I put, like, ingredients like cookies. Not cookies. Let's say I put ingredients for cookies like sugar, flour, butter, and chocolate chips. What am I going to get out of this machine?
Pizza.
No. Will I get pizza out of it? No, you won't. You won't get pizza. Okay? You only get chocolate chip cookies, right? Does that make sense? Just like if I were to put like tortillas, some carne asada, some tomatoes, onions, lime, cilantro, little like a Tapatio bottle. What am I gonna get out of the other end?
A burrito.
Tacos, right?
What? You could get a
Tostada.
No, you won't get tostada because I don't. It's not a. Okay, good. Okay, if I put ingredients for tacos, am I gonna get something out like a dog?
Yes.
No. Wow. Okay. Okay, kids. Good. So, can we be serious though? If I put in ingredients for tacos, am I gonna get a dog? No. Okay. Thank you. Okay, so in the math, we have these things called functions. It's like a math machine. So I'm gonna look up here, please. Let's say I had this machine. Okay. And let's say there's a hole in the top of it, and on the side of it that there is like a little conveyor belt that comes out. Okay, and you get your product. Okay. So I'm going to put ingredients into the machine here, and things come out of it, okay? Let's say our math machine had the ingredient, or it said that the math machine said 2x, okay? And that the ingredients are the x's, okay? So ingredients are a list of x's. These are ingredients. Let's say an ingredient is 1, another ingredient is 0, another ingredient is -3, and let's say another ingredient is 1/4, okay? What happens if I put 1 into this machine? Okay, I put 1 in. What's 2 times 1? 2. So what will I get out of it?
2x.
No. 2, which is 2. 2 times 1 is 2. So the output would be my y's. Okay, it's 1. Okay, what happens if I put 0 into this machine? What do I get? Y 0. 2 times 0 is 0. Are you following me right now? What happens if I put in -3 into this machine? What do I get? -6. Good, because 2 times -3 is? Good. Okay. Let's keep going here. What happens if I put 1/4 in this machine? 1/2. Right? What's 2 times 1/4? 1/2. Does that make sense? This machine just doubles everything. Okay. What happens if this machine put a negative? What happens to my answers if I had a negative sign here? Let's say I put a negative sign on this machine. What would it change? Yeah.
It would be double, but then it would be negative.
Good. It would be double. So what's 2 times or -2 times 1 is? Oh, okay. Oh, there's a mistake right there. Why didn't you tell me? This is supposed to be a 2. So it's -2, right? 0. 0 times -2 is still? Good. -3. Oh, it's supposed to be times a -2 is? +6, right? 1/4 times 1/2 is, or 1/4 times -2 is? -1/2. Make sense? Okay, good. I hope it makes sense. Okay. So, function rule is an equation that creates an output for every input. We talked about that. That's like our math machine. And function notation is the written of f of x. That's the name of the math name. Function notation. It looks like this, f of x, okay? That's how you say it. This is like another name for y, okay? Here are the steps if you're on the lesson. Why isn't it working? Okay, if you're on the video, these are the steps. If you're going to do what we're doing today, we're going to use the three-part table. It's going to think about the math machine, that concept, okay? Here we go, graph 1 and 2. Okay, 1. F of x is equal to x plus 1. So this column here is going to be our ingredients. These are our x's, and this is like our math machine, and this is our output. Okay, does that make sense? So the ingredients I only want you to use today, we're going to use simple ingredients. We're going to use -2 as an ingredient always. We're going to use 0 as an ingredient, and we're going to use +2 as an ingredient. Can we use other ingredients if we wanted to? Yes, but today we're only going to use these 3 ingredients. What 3 ingredients are we using today? -2, 0, and 2, right? These 3 ingredients. Good. Okay, so this middle column is like, what does the math machine doing? Okay, so y is equal to x plus 1. We're saying that our answer is going to be equal to x plus 1. So we plug in -2 for x plus 1. What's -2 plus 1? What? -1, right? That means that if I were to plug in -2 as my ingredient, I'm going to get out -1 as my output. Does that make sense so far? This is the math machine in the middle. These are ingredients. This is the output. Okay? What happens if we put 0 into my math machine here? This function. What's 0 plus 1? What's 0 plus 1, everyone? 1. That means if I put in 0, I'm going to get an output of 1. Good? Does that make sense so far? What if I put in 2? 2 plus 1 is 3. That means if I put 2 as an ingredient, I get 3 out as my output. Okay? Show me thumbs up, thumbs down if you are good or bad. You want me to explain anything? Y'all good? Okay, so now we're going to do what we did last week. Remember how we graphed these? These are all ordered pairs. You see these? Remember this from last week? Yep. I hope so. We're going to do what we did last week. We're going to make a graph. So this is from last Friday, I think, right? We did a quick lesson on this. Okay. What scale should I use down here? Should I go by 1s, 5s, 10s, quarters? What do you think? 1s? You think that's a good idea?
Yeah.
I think I'm going to go by halves. Watch. I'm going to skip every other box. Will be 1, 2. Why do you think I'm skipping a box? What's the biggest number in my answers? 3, right? So do I need to go by 1s? No. Doesn't matter how I do this. It doesn't matter. It just will look nicer, I think, this way. So you're going to still do some graphing like you did last week, and you just have to get used to it because we will be working on graphing for the next few weeks here. Okay. Now we just plug these in. -2, -1. Go to -2, down to -1. We're going to plot a point right there. Okay. Then we're going to go to 0, 1, so 0, and then up 1 to right here. And then, of course, 2, 3, we go over 2, and then up to 3 right here. Okay. And then we're going to use a straight edge. And we're going to connect the dots. Kind of straight. I hope that's straight. Okay, so I got a question for you. Can you predict what happens if I put 3 in my math machine? What would I get out if I put 3 in my math machine? Look at where my graph is. If I put 3 as my ingredient, what should I get out? When I look up here, where does it go up to? 3. Well, don't you think it would be up to 4? Does that make sense? What happens if I put -3 in my math machine? What number should I get out? What? -1. Y'all see that? If I put -3 in my math machine, let's look right here. -3. Look down at the line. Where is it crossing at on the y-axis? -2. Do you see how the graph works? A graph is the picture that shows us what the math machine is going to do, or the function. Okay? Thumbs up if that makes sense. Thumbs down if you want to repeat myself. I need all thumbs up above your heads because I can't see them, okay? So y'all got it. Okay, good. Let me do number 2 now. Number 2. Okay, I'm going to use the same ingredients. You got -2, 0, and 2. Okay, and we're going to just plug it in. We got 3 times -2 plus 4. So we're using PEMDAS here because we're not solving. We're just working it out. What's we're gonna do multiply first. 3 times negative 2 is negative 6 plus 4 is negative 2. So that means if I put in the ingredient of negative 2, I'm gonna get out negative 2. The same output. That's just what happened this time. Let's put in 0. 3 times 0 plus 4. What's 3 times 0? 0 plus 4 is 4. Good. Okay, so we got 0, 4 as your output, right? Next one, 2. 2 times 2 is what? 4 plus 4 is 8. That means if I put in 2 in, I get 8. Okay? So now I'm going to make my graph. These are my ordered pairs. Okay, what scale should I go by on this one? Ones, twos, halves? Yes, sir. Oh, 3 times 2. Yeah, you're right. I messed up there. Thank you. Right here? It's supposed to be 3 times 2. Thank you. So what's 3 times 2? Okay, 6 plus 4 is 10. Good. Okay, thank you. Okay, so continuing on here. What points do you want to use? What scale do you want to use? Let's look. Twos, right? Why'd you go by twos this time? 2, 4, 6, 8, 10, right? What's the biggest number we're dealing with here? 10, right? What happens if we go by ones? We got 1, 2, 3, 4, 5, 6, 7. Do we have enough room for 10? No, it's good. So we're going to go by twos, right? So I'm going to skip every other one. So I'm going to go say this is, because I know that this first one is 2, so I'm going to say this is 4. Skip 1, this is probably 6 and 8, and then we got 12, right? Is that good? Does that work for you? That making sense? Every other one's 4, so we got 2, 4, 6, 8, 10, 12. Okay. Same thing here. Okay, so now we're going to put in our order pairs. -2, -2, so we're going to go -2 down to -2 here. Plot a point. Then we got 0, 4, plotting our point. And then we got 2, 10, plotting our point. Taking our graph. Taking a graph now, and we're graphing both sides of the equation, okay? That's it. That's how we do it. Now, can we predict? I want you to predict. If I were to look at this graph, if I put in -6, what should I get out? So if I put in -6 as my input, what should I get out of this math machine? Turn your neighbor, discuss what it should be. Okay, what do you think it should be? If I put in -6 here as my input, what should I get out as my output? What? 20? 14? -14? I'm hearing a bunch of answers. 22? I think you're confused. Okay, this is how I would do it. I put in my math machine, -6, right here, right? That's my input. Where's the graph? Is it above or is it below here? When I look, it's below. How far down is it? Down to -14, -14. Okay, so we use the graph to predict what's happening, okay? All right, anyways, that's how you do numbers 1 and 2. Number 3. Quiet down. Actually, let's make it fun. Let's go just straight to number 4.
Oh, number 4?
Yeah, number 4. Okay, write down number 4 for me. You're going to do this on your notes, please, and then we'll do the graph at the end on your iPads, okay? So your iPad should be off and down, put away. Here we go.
Wait, so
We're doing number 4 right now. You're writing down the table because that's what you need to be doing. Okay? So number 4, we're going to start with our 3 inputs. What are the 3 inputs we're using today?
-2.
Good. Do we have to always use these inputs?
Yes.
No, for today you do, but in the future you can use whatever you like. Okay? Now we're going to plug these in. So I know there's a fraction there, but don't let it fool you. Don't let it get you down. Let's just put in our x. So we have 1/2 times -2 plus 4. Okay, let's work this out. What's 1/2 times -2? No. What's 1/2 times -2? If you have a $50 and then you have 2 of them, how many do you have?
$1.
Oh, you get that?
I knew that.
If you have a $50 and then you get 2 of them, how much money you got?
$1.
If you have a $50, you have 2 of them, it's $1. Are you being serious right now? Because I want you to be serious. Okay, so what's 1/2 times -2? Good. -1 plus 4 is +3. Okay, so if I put in -2 into my math machine, what will I get out? 3. Okay, what happens if I put 0 into this math machine? What do I get?
We'll get 4.
It's 0.
No, you get 4. What's 1/2 times 0?
Oh, yeah.
0 plus 4 is?
4.5.
Okay, are you guys being serious or are you being silly right now? I could sense the silliness because I see you laughing and giggling after each answer. So, are you guys being serious? I want you to be serious in my class, otherwise it's a waste of time.
Damien's always serious.
I want you to be, I want us to have fun, but I need you to also be telling me honestly what's happening. Okay, so 1/2 times 0 is?
0.
0 plus 4?
4.
Thank you. Next one, let's put in 1/2 times 2. What's 1/2 times +2? 1 plus 4 is?
5.
Good. Good, start graphing it for me and I'll graph it too. You could use your iPads. They have graph paper on there. So, on this, we're gonna what scale should I use here? Should I go by 1s, 2s, 5s, halves, quarters? What do you think? Okay, I'm gonna go by 1s, which is okay. If you did another one, it's fine. I don't think it matters. So I'm gonna go. Every other one's gonna be 2, because each one of these is gonna be that's 1, and then 2, and then 3, and then I'm gonna actually put one here for 4, right? Underneath 5, 6, right? Then we got -2, -4, -6, and over here we got -2, -4. Here we got 2, 4, right? So over here we got -2, 3, -2 up 3, 0, 4, 2, 5. Okay, there's your graph. Most of yours look like this. Raise your hand if you have any questions on this. Okay, now I got a question for you. Let's predict. What happens if I were to put -4 into this math machine? What would we get? Turn to your neighbor and describe what you would get if you put -4 into this math machine. Okay, what would we get if I put -4 into this math machine?
2.
Good, we get 2, right? Look at, we start at the x-axis, so we say, look right here at 4, right? And then we're going to look at right straight up. Where is it at? It goes up to 2, right? What happens if I put 6 into this math machine? Turn to your neighbor and tell them what you'd get. What happens if you put 6 into this math machine? Okay, what would we get, kids? Okay, look at 6 right here. Okay, you all see 6? Okay, looking at 6, look straight up. How many boxes does it go up to until we get here? Let's count. 1, 2, 3. So if I put 6 in this math machine, what do I get out? 7. Does that make sense? Okay. You should be able to read a graph. Sometimes on a test they'll say, here is a math machine. What will you get out? Okay. Good?
Yep.
Okay.
Cupcakes.
Cupcakes, good. I know that this is like new stuff, so we'll take time to practice because at the end of the day we just need to practice, okay?